differentiate g of x equals the quantity x squared plus 5 over x squared minus 5, all raised to the 6th power. Now, in the last problem, we had to differentiate a function that required the chain rule and the product rule. Here, we're going to have to use the chain rule and the quotient rule. So if we look at what we have, this whole thing is a function raised to the 6th power. So the inner function is this fraction, this rational function, and the outer function is raising that to the 6th power. So the outer function is u to the 6th. If we apply the chain rule here, the derivative of u to the 6th is 6u to the 5th. So that's going to give us 6 times the fraction x squared plus 5 over x squared minus 5 raised to the 5th power. And then we have to take that and multiply it by the derivative of the inner function. So we have to differentiate that fraction, x squared plus 5 over x squared minus 5, which is going to require the quotient rule. Now, I'll remind you, for the quotient rule, we have that mnemonic where we have low d high minus high d low all over low squared. So we're going to have to do that when we're differentiating this rational function. Now, I'm going to leave that first part out front because we've finished that. We're just going to leave that alone. And then we have to use the quotient rule here for this. So let's go through and do that. We've got low d high. The low function is x squared minus 5 times the derivative of the higher function. The derivative of x squared plus 5 is 2x. And then minus the higher function, which is x squared plus 5, times the derivative of the lower function. Well, the derivative of x squared minus 5 is also 2x. So both of those are going to be multiplied by 2x. And then that's all going to be over the lower function squared. So x squared minus 5, quantity squared. Now, because both of those terms in the top, both of those portions in the top have a 2x in them, we can actually factor out that 2x, and then all we'll have to do is distribute the subtraction to that second x squared plus 5. So what I'm going to do, again, I'm going to keep the first part the same. And then I'm going to pull out that factor of 2x. And then let's see what's left over in the top. We've got that x squared minus 5. But then when we distribute the subtraction to the terms in the other polynomial, that's going to be minus x squared and then minus 5. Because both of them are going to become negative all over x squared minus 5 quantity squared. If we look in that numerator, there's a little bit of canceling we can do. We've got a positive x squared and a negative x squared, and those are going to go away, and we're left with negative 5 minus 5, which is negative 10. So this is going to end up being negative 10. And there's a couple of things that we're going to be able to do to simplify things. The first thing I want to do is I actually want to take this whole fraction being raised to the 5th power, and I want to split up the numerator and denominator. I want to write this as x squared plus 5 to the 5th power over x squared minus 5 to the 5th power. If you don't see why I'm doing that right now, you will see in just a moment. And then times, now the right-hand bit, we've got that 2x out front, and it's being multiplied by negative 10 in the numerator. So that's going to be negative 20x up top. And then in the bottom, we've got x squared minus 5, quantity squared. Now, hopefully you can see why I've split up that big fraction. Now, if we look at the denominator, we see on the left bit, we've got 5 factors of x squared minus 5. And on the right, we've got 2 more. So that means in the end, our denominator is going to be x squared minus 5 raised to the 7th power, right? 5 of them from one bit and 2 of them from the other bit. And then in the numerator, negative 20x times 6 is negative 120x. And then that is times x squared plus 5 raised to the 5th power. And that is the final factored form of the derivative.